Okay, welcome back to the basic Python course. This is the last session today, and we wanted to have a look at stimulus presentation in Python, or in other words, programming little psychological experiments. So the most prominent Python package, not the only one, but the most prominent Python package for stimulus presentation is PsychoPy. And PsychoPy basically allows you to control all aspects of such psychological experiments as long as they are run on a computer. So everything that we can do with the computer screen, keyboard, and the mouse, and possibly other input devices. If you're following the in presence course, there's an installation guide for how to install PsychoPy on the Moodle. You can also have a look into the installation guide that PsychoPy itself suggests for Anaconda. This is the one which worked best for me. And if you're following these instructions, you will have a new environment in your Anaconda navigator. I call this PsychoPy. And from this, I'm now launching Spyder. Good. So what will we learn today? Today we will code two little experiments. One of them very simple, the other one more advanced. Still, both of them pretty basic. We will code two little experiments, and during that process, we will get to know several structures in PsychoPy. We will learn how to set up simple windows and place stimuli in them. We will activate PsychoPy's clock for timing. This is, for example, important when you want to record reaction times. And we will see how we can access the behavioral data, so the subject's responses in PsychoPy. For the second experiment, we will then also have a look at how to present picture stimuli rather than just text or words on the screen. We will organize our trials using PsychoPy's trial handler. You will see later on what that means exactly. And we will learn how to automatically save the results with PsychoPy rather than creating the log files on your own, which you can also do, as we will see in experiment 1. Okay, so without further ado, let's dive right into the experiments. So here's our instruction or our objective for experiment 1. We want to write a program, should be called rt.py, that displays letters in the center of a stimulus window. It asks the user, or the user is supposed to press each letter as fast as possible. Then it records the user's response and reaction time and writes all that information into a results file on a try-by-try basis. Okay, so meanwhile, PsychoPy has launched. And I am here switching to a dedicated folder for experiment 1, which is so far empty. And we're starting a new script. So in the previous courses, I was mostly typing commands into the console to see what they do and to see what result they produce, what variables we get, what plots we see, for example. Today will be a bit different. Today I will be doing what the programmer is usually doing, namely building a script from scratch or building a script based on an earlier script. So this is more common mode of work for a programmer, I would say, when you're given a certain task and you're simply writing a script, run it and test, run it and test, and in order to fulfill this task. Okay, so we have opened a new file and I'm now saving it under the name RT, as the instruction says. And obviously what we have to do first is we have to import PsychoPy in order to be able to work with this. We are going to do this as follows. From PsychoPy, import visual, core, and event. So like other Python packages, PsychoPy is also organized into submodules. And we will today need these 3 submodules. But for the second experiment, we will later need the 4th one. So visual is just a submodule which opens windows and allows to display stimuli in them. Core performs core operations, such as timing when things happen. And event is a submodule which collects events from input devices, such as the keyboard and the mouse. Okay, we will immediately use the first of these, namely visual, to create a window. This is done by calling the function window from visual. And we're going to save the result of this operation into a variable called win. So at the moment, this is not really meaningful, but consider this variable win just to be a generic window object, which we will later reference in order to place stimuli in the window, for example. So I'm going to create this, to call this create window object. Something that I recommend is also just when you start writing script in PsychoPy, include one command at the end saying window close. So calling the method close from the window object. This will close the window at the end of your experiment. And in this way, you avoid trouble, for example, having a window open from a script that has been aborted or finished. And then you have to sometimes restart Spyder, which we do not want. So we here close the window. Okay, next, we want to see stimulus inside the window, so we create a stimulus. The visual also includes a function called text stimulus, and it needs several input arguments. First input argument is the window in which the text stimulus should occur. Second input argument is a keyword argument specifying the color of the text stimulus. You can here, I believe, specify RGB RGB triplets, or you can also use fixed set of words to specify the colors. I believe this works with basic colors and colors which are a mix of 2 other colors. So let's just use green, which is one of the basic colors in the RGB colors. And then we also specify the position via the keyword argument pose. And position is a tuple consisting of 2 values, which give the position of text stimulus inside the window, where 0, 0 corresponds to the center of the screen, and 1, 1 would probably correspond to the upper right corner of the screen. So the result of this we write into the variable stimulus. And this is our stimulus object that we later wish to interact with. So in order for a stimulus to appear on PsychoPy, you have to do two things. You have to draw the stimulus and you have to flip the window. Commands for this are pretty easy. You use the method draw from stimulus, you use the method flip from the window. And this ensures that the stimulus is being displayed. So with the commands that we've written so far, we have just created window and stimulus object, but we have not actually shown them. You can understand these commands as saying something like, please refresh or update the screen to what I have configured it to show. Okay, then we remember that we also wanted to record reaction time. And in order to record reaction times, we need to measure the time that passes between display of the stimulus and subject response. So we need a clock. Clock is contained in PsychoPy's core module. And we call this the timer. And when we're displaying the stimulus exactly at this time, we're also resetting the timer. This means that we set the clock to 0 at the time of stimulus presentation, which will then allow us to read the clock later on when the subject gives their response. Okay, how do we do this waiting for the response? Well, there is a function in the event submodule called wait keys. And wait keys basically just pauses the program and waits until any key is pressed or any button on any input device is recorded. Could also be the mouse, for example. And as an input argument, we give it the timer that we have created earlier on as the keyword argument timestamped. So we have set the timer to 0 at the time of stimulus presentation, and now we are measuring how much time has passed. In order to be able to read this, we have to save the result of this waiting for button press into a variable, which we call result. Okay, so in order to understand what this result variable contains, let's at this moment once run the script and see what we get. But in order to do this, we need to fill the text stimulus with information. So the stimulus object has a property called text, and we were supposed to show letters on the screen. So let's just start with an A. Um, so I'm saving the script and run it. So let's see what's happening. I get a message from Pygame and PsychoPy, and I get some incomprehensible error messages just at every time with Python. And I see a new window down here. Click on this window, and then there is a window showing the letter A. And I will react to this by also pressing the letter A on my keyboard. And now the script has finished. Let's have a look into the variable explorer, what kind of results have been created. Okay, there is the variable result, and the variable result is a list. So let's have a look at the first element in this list. The first element is again a list. So let's have a look at the first element in this inner list and the second element in this inner list. So the first element appears to be the response that I have given, so the key that I've pressed. And a second element appears to be the reaction time. So it has taken me 26 seconds total from presentation of the stimulus until my response. Okay, great. Now that we have this information, we can obviously use it to record the subject's response, because we can save this as the key the subject has pressed, and we can save this as the subject's reaction time. Okay, so we have now presented one letter on the screen, but obviously we wanted to show many letters in multiple trials, and the subject is always supposed to press those letters. So what do we need in order to repeat our code and present the stimuli multiple times? Exactly, we'll need a loop. And for creating a loop, we first need an iterable object. And as an iterable object, we will create a string of letters. A, B, C, D, F, G, H. So let's just pick the first eight letters from the alphabet as the stimuli of our experiment. So this is the variable across which the loop should run. So we say for letter in letters. This will be our main loop. What do we have to do in order to make this happen inside the loop and not afterwards, outside? Exactly. We'll have to indent it in order for Python to know that this should happen inside the loop, and this is what we want to repeatedly perform or execute. So in the menu here, you can click edit and then indent, or you can just press tab. Okay, so the way we have it now, we are repeatedly showing the letter A. So in order for this to work properly, let's change this to letter, and we are additionally uppercasing the letter. So this is the string method for uppercasing letter, and since an individual letter just a one character string, we can here apply this. Okay, next we want to prepare our results file. So for this, we have to specify a file name. File name should be results CSV. So we want to produce a comma separated values file. And we open this file name. We open this file. If we want to write to this file without getting an error message, we need to set the mode to W in order to have writing rights. And we already include a header line into this file saying letter, comma, answer, comma, RT, \n, switch to the next line. So this is the structure that we want our CSV file to have. It should have 3 columns, and each line will be composed of these 3 informations: what the letter in the trial was, the button that the subject then pressed, and the reaction time that it needed to do this, to do so. Okay, so we have prepared our results file, and now we need to write into our results file inside the loop during each trial, and not just before the experiment. So we can just call f write again. It writes into the open file. Say letter plus comma plus key plus comma plus reaction time. So this will remember that plus, when applied to strings, is used to concatenate the strings, to chain these strings together. So this will create a string which consists of a letter, then a comma, then the key the subject is pressing, then a comma, and then the reaction time. And because the reaction time is a float, we have to convert it to string in order for that to work. And I've forgotten one thing here, namely the new line character, which we also need in order to move to the next line when writing the file. It is always good practice to close the file when you're done writing. So that's also this. Great, 1A. Okay, it's another time for running our script again, I think. So let's press the letters that we see on screen. A, B, C, D, E, F, G, H. Okay, and now we see that there is a results file, results.csv, and I can directly open it here in Spyder editor and see our very nicely produced comma-separated values file. So we have for all the 8 trials, the letter, the button that was pressed, and the reaction time. Very good. So let's now do a few cosmetics to our script. I will make the writing of the trial info a bit more elegant by here defining a template string consisting of 3 placeholders and then filling this template string with information down here. This will make our code a bit longer, but perhaps a bit more transparent what we are actually doing. So we can then just write this trial line. And let's also print it in order to have the output on the console to not always have to look into the results file. Finally, we want to open the results file after the experiment has been done. And for this purpose, we import the module web browser. This appears a bit strange at first glance because why should we need a web browser for opening the results file? Well, this is more maybe a workaround because web browser has a function called open. And the purpose of this function is to open a file specified by its file name with the program that is associated to this file type on the operating system. So CSV files on my computer are associated with Microsoft Excel, so we should see Microsoft Excel pop up. Let's run the script another time. And let's this time also press wrong keys. Okay, so first thing that we see is that the result file indeed opened. And second thing we observe is that the results now also have been written to the console according to our instructions. Okay, at this moment, you can add sections to the script. For example, we can call this part 1, which is doing the imports. And we have a part 2, in which we set up everything PsychoPy in order to later interact with this. Then we prepare the experiment itself, including the stimuli that appear. Then there is the main loop. And then we have one section at the end, which basically cleans up everything for us and closes the window file and concludes the experiment. So you can section your script like this, always leave a bit more space between sections. For me, that often helps to keep the overview and don't get lost in all the code, especially when code becomes longer than this. We should also fill the doc string with information. Okay, great. So, that was the first experiment. And now let's have a look at the second experiment. Before we go on to the second experiment, are there questions? Oh, I can take questions here, of course. Of course, this is just a YouTube video. So then let's immediately move on with experiment 2. So again, we want to write a little script. It should be called crust.py. We'll see in a minute why this is. In this experiment, we will present images of crabs and lobsters to the subject. The files that you need for this are can be downloaded from the Moodles for those who are taking presence course with me. And then the subject is supposed to categorize them with the left or right key. The user should also have the opportunity to quit the entire program or experiment by pressing Q. And we again record the user's response button press and the reaction time, but this time we'll do this differently than before and store all those results in CSV file, which we have already done in the first experiment, but this time we want to let PsychoPy write this automatically without having the burden to do this ourselves. So we move to Spyder, and what I will do this time is I will not start a new program from scratch, but I will use my program for the first experiment to build on it. So that's what often happens in programming or coding. You don't start every application or script from scratch, from an empty file or sheet, but you often build on previous code that you have written because it obviously saves time. And we will also do this now. So I'm going to save this in the dedicated folder for experiment 2 and call it crust.py. And now I'm going through the script and remove and delete what I will basically not need. So I will not need the web browser this time. And so I can also remove this. We are leaving the import from PsychoPy and the creation of the window and the closing of the window. We will not have text stimuli this time. We don't need this. We will be using the key, the timer. We will not have letters this time, but picture stimuli, which I will show to you in a moment. There will be again a main loop through trials. So I think I leave this here, but comment the loop instruction. And I also comment this because it has to be different. We can keep the display of the stimulus and waiting for key press, but if we can delete everything down here. Okay, so what we have arrived at now is something like a skeletal version of our earlier script, skeletal version for PsychoPy experiment, that we are now going to fill with more information according to achieve what is required from us, according to experiment 2. Okay, so the first thing. Okay, sorry for the brief interruption. I had to pause the recording because the battery of my headset is down. So you will now, from now on, hear me through the microphone of my laptop, and I hope that that's okay. So where was I? I wanted to show you the image files. So for that, I'm going to the folder. So on the Moodle, you'll find a collection of files named files.zip. And inside this, there's two things. There is a CSV file called trials.csv that we will have a look at in a moment. And there is this folder called images containing 6 images of 3 crabs and 3 lobsters. Okay, before we can start with the experiment, we have to specify those as image files. So I'm now going to change these 2 sections here. Files, I will simply list them as a list of string file names. There is crabs, okay, we will get back to this list later on, but now I want to introduce you to the second bit that was contained in the files, which is the trials.csv. And if I open this, it looks as follows. So this is a CSV file, and since there's one comma on each line, it appears to have two columns, and the columns are called image and type. The first column, image, is just the file name of the image file, and the second one is the category to which this is belonging, crab or lobster. Okay, so we will now load this trial file, but we will not load it with pandas in order to have this information as a data frame. We will load it with PsychoPy, because PsychoPy can use this to later on produce many trials from these 6 trial types. So I'm going to add a new submodule to the list of imports up here. It's called data. So data can import conditions from files and can also handle and organize trials. So from the submodule data, we now function import name, and we're going to call the result of this operation trial types. Okay, so what can we do with those trial types? We can obviously use them to sample many trials in psychological experiments. This in PsychoPy done using the trial handler. So now the trial handler. Okay. The trial handler needs as input arguments the trial types. So here we have 6 trial types. Please don't think of these 6 trial types as experimental conditions, because I would say there's just 2 experimental conditions here, crab and lobster. Think of them more like unique identifiable trials. Yeah? So we have 6 different trials that we can possibly create because we have 6 different images. And then we are specifying a keyword argument called nreps. nreps stands for number of repetitions. So this is the number of occurrences for each trial type, how often each trial type occurs. We also specify a method for sampling trial types. Here use random. This will mean that the trials are drawn randomly, but without replacement. So each trial type is taken 2 times, and none of them is taken 1 or 3 times, for example. And this we call trials. Okay, before we go on, I want to show you how to use another keyword argument from the trial handler called extra info. And before we do this, we have to read the subject ID. So let's suppose that before the experiment starts, the program is querying the subject ID from the user of the program, which can be, for example, the experimentator running the study. And the idea behind this is that you maybe want to run an experiment multiple times and want to have saved the results from different subjects under different file names, obviously. So once we have gathered the subject ID, we can, as I already said here, have another argument called extra info. And extra info must be a dictionary where the keys are the names of the variable or the header of the column that they should later have in the log file. And the values should be the value that is being put into this column. So it may seem a bit counterintuitive here to add the subject ID as an information to the trials, because the subject ID is constant across trials. But often when you have data from psychological experiments shared, or you find them on the internet, they are summarized as one single table of experimental data. And if you have the log files from all the subjects concatenated to each other, it's obviously good to have a column in this table saying which subject each line or each trial is belonging to. And that's what we here also want to create. Okay, before we load the stimuli for presentation, let's do one last preparatory step, which is, so this time we don't want to allow all the buttons to be pressed during the experiment. So we specify the allowed buttons. And this we do create as a dictionary, where again the keys stand for the buttons that could be pressed, and the values stand for what meaning this key should have inside the experiment. So left should correspond to the response. Crab, right should correspond to the response. Lobster, and if the user is hitting the key Q on the keyboard, that should mean quit. We will get back to this dictionary later on when we are presenting the stimulus. Okay, then we need to generate the image stimuli. In visual, so from visual, we previously used text stim, and now we use image stim. Once again, as first input argument, this needs the window in which this stimuli appears, the stimulus appears, and it also needs the image file itself, which we specify as the file path. We haven't specified the file path, so let's specify. The file path should be a relative folder name containing the subfolder images and the name of the file, where the name of the file is taken from this list of file names that we have created earlier. But the file name is not specified, so let's specify the file name by creating a loop which is running across the entries of image files. So for each file name which is in this list of file names, take this file name, use it to generate a file path, and then use this file path in order to create an image stimulus. And save this as an image. But in order not to overwrite the image every time, let's create a dictionary which stores each image under a key corresponding to its file name. So this will give us a dictionary where each key value pair corresponds to one picture stimulus. And the key to this, or the label of this picture stimulus, will be the file name, and the value will be the picture stimulus itself. In order for that to work, we need to create an empty dictionary here right at the start of the loop. And this is our code. Okay, so with that, we can now take a look at the main loop and finally start modifying how the trials are being presented. So first, what we have to do is we have to modify the header of the for loop, so how the loop is introduced. And this time, the loop is not running across the letter stimuli, but it's running across trials, which we have previously organized with PsychoPy's trial handler. So the type of this variable is an ordered dictionary. The fact that it's ordered means that we can iterate through it. So we will here use the iteration variable t for trial to go through all the trials, which PsychoPy has automatically sounded for us. And the fact that it is a dictionary means that we can access it with keys or labels. So, for example, the entry image in each trial will correspond to, switch to will correspond to what was in the column image for this particular trial. And label type will correspond to what was in the column type for this particular trial. But here we need image, and we know that in the column image we have file names, and we have also used the file name in our dictionary of picture stimuli. So we can access the picture stimulus of the current trial by accessing the dictionary images and saving this as our current image, so as the image in this trial. Once again, we need to draw the image and flip the window such that the picture stimulus is also being shown and not just configured. So we are refreshing the screen. And then again, the timer is reset such that we can record the reaction time. So this just stays as it is. This is our section for gathering the subject's response. And in wait keys, we will now add a second input argument called key list. So as I already said, we only want the user to press a set of designated keys, not being able to, for example, to continue the experiment by accidentally pressing something else. And what are the allowed keys? Well, the allowed keys are keys that are defined as labels here in this dictionary. And this dictionary key meanings. So left, right, and quit will be the allowed keys. And we can extract those from the dictionary by using the method keys, as we learned early on. So this means that we can now also code the answer that a subject response is corresponding to by just accessing the key meanings dictionary and calling it with the dictionary. So when the subject, for example, is pressing left, then the value of this will be left. And if we insert left here for indexing the dictionary, we get crab as the answer. If we insert right, we get lobster. If we insert Q, we get quit. So this corresponds to the semantic answer that the subject wants to give in this try. Now, obviously, we can check whether this answer is correct. So we can say the answer corresponds to the current experimental condition. Then this is a correct answer. We said correct. Yes. Otherwise, we said. Okay, so how does that work? Answer, as I said, is either crab, lobster, or quit, depending on what the subject has pressed. And T type is the information from the column type for the current trial. And in the trial type specification file, this could either be crab or lobster, which is why we can then compare it to the answer, which is also either crab or lobster. This allows us to check correct. You can also store this information for later saving using the trial handler again. So the trials that we have earlier generated using the trial handler have a method which is called add data. And there we can add an information for the current trial, which consists of the and the value we want to store. For each trial, we want to store the answer that the subject has given and whether it was correct. For completeness, we can also store the reaction time for each trial, because we have also extracted this from the result that Wade Keys has given us. One thing I have forgotten is that here I need the OS module for interacting with the operating system, so I have to add Okay, this is maybe a good moment for running our script and testing it to see whether everything works as we want it to work before we then finally come to a few more key changes. Okay, the script is asking me to insert my subject ID. I will now just use my initials. You could also use 001, 002 if you're numbering the subjects according to some system. And now we're being shown something. So one reason we were loading all the image files before the main loop and not inside the loop was that we didn't want to, so we wanted to have the picture stimuli loaded beforehand and not have them being opened inside the loop, but already have them available in memory before the experiment already starts. This sometimes solves problems. So this is not responding. We just type win close. Yes, this closed the window, and I just see that I here forgot NS, which files, and therefore this loop didn't work. Okay, let's try one more time. Okay, and now we are seeing actual pictures. Very nice. So what was it? Left was crab. Left, right, 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 left, right, if I'm correct. Okay, good. So the experiment has obviously succeeded and everything has happened, but we don't see any results, which is trivial because we have not yet saved any results. And I already said that this time I want to do that differently, not having to create the CSV file ourselves, but letting PsychoPy do this for us. And in PsychoPy, there is a method of a trial handler object called save as text. File name, which we will create in a few seconds. It needs to, you need to specify a delimiter. We here use comma because we want to again create a comma separated value files. Could possibly also create a tab separated value files. Then we set append file to false in order not to append trial information to existing trial information, but create a new file from the start. And we define the file override. So if the file already exists, it's being overwritten with new information. And now let's generate the file name. The file name should be results underscore plus .csv. So if I'm entering JS as my subject name, the results file will be called results underscore JS.csv. As a bonus, also print the results that we are writing into the file so that we don't have to open the file. Results is what we get as an output from save as white text. Okay, one last thing. So let's actually do this. Let's actually try it out before we add this one last thing. Okay, this time I'm going through more quicker and also giving wrong answers. Great. So this is the output that we get from automatically saving it. I can also open this here in the editor. But in the console, you always get a nice overview. So what do we have in this results file? We have, this appears to be a data frame where each row consists
corresponds to a trial, and each column corresponds to some information about this trial. There is a subject column because we have configured this using the extra info keyword of the trial handler. Then there's the trial number, just from 1 to 12. The image that was being presented in the trial, and you can see that each image occurs twice. Then the type of the trial, which is not shown here on the console, but it's in the file, lobster or crab. So these two are taken from the trial specification file that we were loading. Then there is some technical information and the information that we have added using the add data feature of the trial handler. This was whether this was the answer that the subject gave, whether it was correct, and the reaction time. And you can see that if the answer didn't correspond to the type of the trial, then correct is correctly set to no. Okay, so the last thing that we need is to implement the quit option. If the answer is one value in our dictionary of key meanings, so it should be returned if the subject presses Q, then the answer should turn into quit. And if answer is quit, we want to break from the loop. Okay, so let's run our script. Time. There's a syntax error because I was writing in rather than if. I'm entering my subject. Now I'm seeing crabs and lobsters again. The task of deciding whether something is a crab or a lobster is called crabigorization. And if I don't want to do crabigorization anymore, I'm pressing Q and I'm out of the program. And interestingly, you can see that the trials which were supposed to come after I pressed Q are already configured by the trial handler, but they just don't have the information that is only created when running them, such as the answer, whether it's correct, and reaction time. Obviously not available because we exited from the loop earlier. So in this way, the log file always gives you the full information about whether trials have been run and what information has been gathered from them. Okay. So this script was called crust because crabs and lobsters both belong to a biological category called crustacea or crustaceans. And this was our second experiment. Okay, so if you're taking the presence course, there are two little exercises as homework to strengthen your PsychoPy knowledge a bit. And with that, today's session would be over. I want to thank your attention again and hope you enjoyed the course. And please also have a look at the other videos. Bye-bye.